Hi all, we'll move ahead with our new topic, Dbms. So asset properties. Okay, so for a transaction, so we have some properties. Okay, so transaction properties also will call it as our asset properties. Okay, so here A stands for atomicity. Okay, C stands for consistency. Then I stands for isolation. D stands for durability. Okay, so what are these we studied? So whenever we are running a transaction, okay, so it has to have atomicity property. Okay, so atomicity is nothing but a transaction in that what all the operations we have, so those all operations has to be considered as a atomic unit, and either it has to complete all entire that all the operations, or it should not perform at all. Okay, so it's something but uh, a transaction you have to consider as an atomic unit. Okay, so it is either performed in its entirely, so the transaction complete whatever operations you have read, write, or manipulation, all the operations it has to perform completely, or it should not perform any of those. Okay, so that's the first one, atomicity property. Okay, then second one is consistency. So here consistency is nothing but the correct execution of transaction must take the data base from one consistent state to the another. So whenever you are performing something, so it should not affect the database. Okay, so database should be there in a consistent state only. Okay, so whenever you are manipulating the any data or any record by the transaction, so entire database should be in consistent state. So for that, we have to look at. Okay, so that is nothing but the second property, consistency, preservation. Okay, and third one is isolation. So here isolation is nothing but a transaction, whatever is there, like it should feel as a only the transaction is running currently. So it's nothing but completely you are isolated, okay, from other transactions. Okay, and it has to run until it get commits. Okay, so it's nothing but here we are saying is a transaction should not make its update visible to the other transactions. Okay, it should not be visible to the other transactions until it get committed. So this is something, but it has to feel as it's only this transaction is running. Other transactions we don't have anything. Only this one transaction is running until and unless it get committed. Okay. So for actually we can't implement directly this one. Like only one transaction is running at the time. Okay. So remaining are not running like that. Okay. So for that purpose, some different algorithms. Okay. So different methods we have. Okay, so those will enforce the like a serializability. Okay, so then your different schedules will run it. Okay, so for this purpose, for the isolation purpose, we have the different algorithms and methods to implement it. Okay, then last one is durability. So once if a transaction changes the database, okay, and then that database, if it is what all the changes are committed in the database, those changes must never be lost. Okay, so because whenever whatever after that, if after commit, okay, if any failure also happened, so those changes should be there always. Okay, so there is a durability. So whenever maybe after 10 years or 15 years also if you're checking it, that whatever changes we have done, that should be there in our database. Okay, that is a durability. So whatever time it will take, so after that also if you're reading it, it has to be there. Okay. So those are the actually transaction properties. Okay, so normally we will not run a single transaction at the same time. Okay, so what all things we will be having and how it will operate, those things we'll say, check it. Okay, so here something we have as a schedule. Okay, or we will call it as a history. Okay, so here, well, previously we were studying, we have studied as a two transactions whenever we were trying to run at the same time. So consider this example. Okay. So T1 and T3, or for previous examples here T1 and T2. Two transactions were there. Okay, so here interleaving things we are doing it. Okay, so only this part. Okay, so here, so what is there is it's a timeline. Okay, consider the here it is started at particular time. Okay, one time. Okay, then after that here it will get over. So in this time. So what we are doing is the T1 and T2 two transactions are came to the system. Okay, so in the T1 some operations were running it, then T2 some operations were running it, then again T1 were running it. Okay, so like that we are interleaving the T1 and T2 transaction. So whatever in this time T1 to T2 here, consider that it started at the particular time A, okay, stopping at particular time B. Okay, so here A to B, whatever time we have. So in this time, so what all things were, what all transactions were interleaving it. Okay, maybe here we are showing as a two. So like that, n transactions we can interleave it. So this entire thing will call it as a schedule. It's nothing but whatever we return here, two transactions, those operations for this time we'll call it as this is a schedule. Okay, this entire thing together we'll say as a schedule. Okay, so here, or we can say that it's a nothing but history also, but maximum times, okay, we refer this one as a schedule only. Okay, that is a transaction history or schedule we'll call it. Okay, but the maximum times we'll refer as a schedule only. Okay, transaction schedule. Okay, so when transactions are executing concurrently, okay, so in a interleaved fashion, okay, the order of execution of the operations from the various transaction form what is known as a transaction schedule. Okay, so whatever we are mixing it, so those things all together will say as a schedule. So a schedule, yes, if you are considering it of n transactions T1 to Tn, so what all things will be there is it is an ordering of operation. Okay, so if you saw that in the previous diagram, in that we have the first T1 transactions, some operations are executing, then T2 transactions, some operations are executing, again T1 transactions, some operations are executing. Okay, so here is the ordering of operations of a transaction subject to the constraint. So depending on the some constraint, we are ordering it. So each transaction Ti that participate in yes. Okay, so whatever transaction n number of transactions will be there. So in that any transaction Ti will take it and will perform the sum operation. Okay, so depending on the constraints, the operation of T1 is in S must appear in the same order in which they occur in T1. Okay, so here condition is, so whatever actual transaction T1 is there, okay, so independent of schedule, okay, so whatever transaction T1 is there, in that what all operations are there, in the same order in schedule also it has to appear. Okay, if T1 contains as a reading a one data item, then writing one data item, okay, and then reading second data item. Okay, so like that, so first read one data item considered as A, okay, so then write that data item as A, then read data item as a B. Suppose this one is there in T1. So in the same order, it should be there in S also. Okay, the schedule whenever we are performing, that is a combination of a number of transactions T1 to Tn. Okay, so combination. So when we are writing those things, in that time, this order in T1 whatever is there, it should be there in S also. Same order it should be there. Okay, that is a reading of operation A, then writing of operation A, then reading of operation B. Whatever we said in T1, same thing it should be there in yes. Okay, maybe it may take some different time intervals. Okay, immediately all three operations will not execute immediately. Okay, so but so it may happen as a T1 transactions first operation will execute, then maybe T2 or T3 transactions some operations will execute, then again T1 transactions second operation will execute. Okay, so it may take some time, but it has to appear in the same order only in S. So however that operations are from the other transaction Tj can be interleaved with the operations of Ti. So whatever we discuss the same thing. So some other transactions operations may be interleaved in schedule yes with Ti. Okay, but order should be same. Now what we are doing is here we are characterizing the schedule. Okay, so here just we studied what is schedule. So we are characterizing the schedule based on the recoverability. So what is recoverability, we'll study it, and then what is recoverable schedule, we'll study it, then we'll say we'll different characters. Okay, so schedules are classified as based on the recoverability. So here recoverable schedule. Okay, so first one. Okay, so what is that meaning? We'll study it. Okay, so here recoverable schedule. Okay, so one where no transaction needs to be rolled back. Okay, so the schedule will say as a in this, so no transaction should be rolled back in the schedule. Okay, and a schedule S is recoverable. So when we'll say as is recoverable is if no transaction T, okay, in S commit until all the transaction Ti that have written an item that T reads have committed. Okay, so here what we are saying is that suppose consider that T dash is one item, it's writing it. Okay, so that item in T we are reading it. So in schedule no transaction T in S should commit it. Okay, so none of the transaction should commit until and unless, okay, so all the transaction T transaction commits it. Okay, so whenever you are trying to commit as the first one, whichever read it, so it has to commit it, then remaining all the transaction has to commit it. Okay, so it means, so whatever you are reading it, it should not be kind of a dirty read also. Okay, so first T dash has to commit, then T has to commit it. Okay, so because T has the written the data. Okay, so that data is read by T dash is written the data. Okay, T is reading the data. Okay, so T dash if it is committed, T also has to commit it. Okay, and in this schedule, no transaction should be rolled back. Okay, so it means they are already performing all the operations whatever are required. Okay, so for the interleaving purpose and for the stability of the database, all those things they are taking care. So in that time, no need to roll back the any of the transactions in S. Cascadeless schedule. So one where every transaction reads only the items that are written by the committed transactions. Okay, here cascadeless in the sense, if any problem comes, if we are rolling back, so from one transaction, one more other transaction, maybe you have to roll back. Okay, so that may like that some conditions may come. Okay, so this is a reverse of that one. So cascadeless, you don't have any cascade property. Okay, so if a transaction is reading something item, okay, so that has to be committed. Okay, okay, so here we are saying is a one where every transaction reads, okay, whichever transaction is reading only the items that are written by committed transactions. Okay, so transaction has to read the items. Which kind of items it has to read is nothing but only committed transaction type of transactions items only it has to read it. Okay, it should not read items which are not committed by the other transactions. Then here, next one, schedules requiring cascaded rollback. A schedule in which uncommitted transactions that are read. Okay, so reverse of this one, whatever we studied here, always committed first. Okay, so if something is some transaction is writing it, so it has to commit it, then only other transaction has to read it. Okay, those items. Okay, so here what we are doing is uncommitted. Those transactions are uncommitted that are read an item from the failed transaction must be rolled back. Okay, so here what we are doing is something is problem is happening like that. Okay, so here a transaction in which uncommitted transactions, so uncommitted transactions that read an item, uncommitted transaction that read an item, okay, from failed transactions. Okay, so here what we are saying is after committed transaction only, so other transaction has to read it. Okay, so, but if it is not committed means it may get failed. Okay, so this is what condition we are saying is if it is failed one. Okay, so what you have to do is you have to roll back it, because whichever data you are reading it, okay, so that is manipulated by the failed transaction. Okay, so whatever the transaction is failed means obviously whatever you are reading is that is a dirty read. Okay, so you have to roll back the that transaction. Okay, so this schedule, entire schedule, will call it as a schedule required the cascaded rollback. So one after another, maybe it will affect the n number of schedule, n number of transactions whatever we have, so those that entire schedule has to be rolled back. Then the next one is strict schedules. A schedule in which a transaction can either read or write an item X until the last transaction that wrote X as committed. Okay, so here, so whatever we had the restriction on for the reading purpose only. So now in strict schedules we have for the writing purpose also. A schedule in which a transaction can neither read or write an item X. Okay, so some item X is there. Okay, so consider that T1 transaction. Okay, so this should not read also, write also, until the last transaction that wrote X. Suppose consider as a T2 transaction, it's writing the X item. So until and unless T2 commits, T1 should not read also, write also. Okay, that item X, it should not read also, write also. It's a strict schedule we are saying it. Previously only restriction was there here. Okay, so on reading purpose, now here for the reading and writing purpose also. Okay, so this schedule we'll call it as a strict schedule. Okay. So next one, this is characterizing the schedule based on the serializability. So here, this is a for the recovery purpose only. So these whatever we had, so from this recovery purpose. Okay, so now, so depending on the serializability. So actually in real time, whatever we'll use it depending on the serializability and recoverability, both will check it. So maximum of times we will be concentrating on the serializable properties only. Okay, so here, what is serial schedule? We'll study it first. Then serializable schedule will study it. Okay, so what is serial schedule is nothing but, suppose in schedule S, I'll say as a serial schedule. If for every transaction T participating in the schedule, so consider the suppose 4 or 5 transactions are there. We consider the 4 transactions are there in schedule S. Okay, so all the operations of T are executed concurrently in the schedule. So consider say 4 transactions are there in S. Okay, so T1 to T4. Okay, so we'll execute T1 first, then we'll execute all the operations in T2, then we'll execute all the operations in T3, then we'll execute all the operations in T4. So what we're doing is serially we're executing all the transactions. We're not at all doing any interleaving things. So this schedule, so whatever will be there, we'll call it as a serial schedule. Okay, so here we're not at all doing any interleaving. Okay, interleaving of the operations, it's nothing but saying that serially whatever transactions are there, those will run it. Okay, so but in real life time whatever we have, this will not happen. Okay, so we can't do like this exactly for each and every schedule. Okay, so this is a ideal one, we can say it. Okay, so it's a serial schedule, but manually whenever you are doing it, we can see it as a serial schedule only. Execution of T1, execution of T2, execution of 3 T, execution of T4, like that. All are independently executing. So that is what isolation property of your asset property. Okay, so here all the 4 are running independent to each other, like that it will happen. Okay, so other than this serial schedule, so all other schedules will call it as a non-serializable schedules. Okay, sorry, non-serial schedules. Okay, non-serial schedules will call it. Okay, so now this is can't be implemented as it is. Okay, so equivalent to this one we can implement. Okay, so that is nothing but we can have the interleaving also. Okay, and result of the schedule will get it equal to the whatever serial schedule will get it. Okay, so like suppose if I am executing T1, T2, T3, T4. Okay, so one after other, so whatever result after that will get it same result if I'm getting it after interleaving that all the 4 things. Okay, so that schedule will call it as a serializable. Okay, so here we are saying as a schedule yes is serializable if it is equivalent to the some serial schedule of the same transaction. Okay, so it's nothing but whatever result we are getting it, if it is same as that of serial, so this is a new schedule. Yes, we'll call it as a serializable. So but in serializable we have the interleaving property. Okay, so you can interleave it, then you can get the result as same as that of serial schedule. Okay, so result equivalent. Okay, so next one is result equivalent. Here two schedules are called result equivalent if they have produced the same final state of the database. So two schedules, after execution of the schedules, if database is in same state, we will say as a both are equivalent. Okay, so conflict equivalent. Okay, so here something will come as a conflict. Okay, so what is conflict is, so read conflict or write conflict. Okay, or read conflict, like that it will be there. Okay, so in real life read is never be a conflict actually. Okay, so combination of read and write operation between the two transactions may perform the may lead to the conflict one. Okay, so this one transaction is reading, one more transaction is writing it. Okay, so we'll say as a read write conflict is there. Okay, or write read conflict is there, reverse. Okay, so maybe first transaction is writing it, second transaction is reading it. Okay, or both the transactions are writing it, so that is a write read conflict. Okay, so this is what combination we'll call it. So both transactions are reading means this is actually not a conflict. Okay, so it will not affect the database, because when just you are reading the values, you are not performing anything operation on the database. Okay, so it will not modify it, so we will not get any kind of conflicts from there. So read write conflict, or write read conflict, or write write conflict will be there. Okay, so three different things, but again in that also we'll combine the first two, that is write read or read write. Okay, so both are almost equivalent, same, just order of thing is a little bit different. Okay, so that is a, we'll say as a conflicts. Okay, so conflict are there in between the transactions. Okay, now we are saying is a conflict equivalent. Okay, so here two schedules are said to be a conflict equivalent. Okay, if the order of any two conflicts operations in the same in the, is the same in both the schedules. Okay, so here we are taking two schedules. Okay, so first of all, this is combination of so many things. So conflict equivalent is nothing but between the two schedules will be there. So each schedule has the transaction. Okay, so consider as a S1 schedule is there and S2 schedule you have. So S1 schedule contains two transactions, T1 and T2. S2 schedule contains T3 and T4. Okay, so actually if you are saying as a two things you are equivalent, you are saying as a, so that time actually we will not take as a different transactions. So in S1 schedule we have two transactions, T1 and T2, and in S2 schedule we will take again T1 and T2. Okay, so both side same transaction, so we are running it, just we are trying to check these two schedules are same or not. Okay, so in S1 also, um, in S1 also actually what will happen, conflict will be there, and in S2 also conflict will be there. Okay, so just 1 second. So consider the S1 schedule, S2 schedule, two schedules are there. Okay, so if this two schedule means, okay, so each schedule will be having the at least one, more, at least two transactions. Okay, so we'll take that minimum only. So more than two transactions it may be there. So here normally we'll take it as a two transactions or more than that. So here we will take two transactions only. So here T1, here also T2. So these two transactions only. So now we are checking these S1 and S2 both are equivalent or not. Okay, so here consider the T1. So some read operation you are doing it on data item, consider as a capital letter A. Okay, then maybe write operation you are doing it on capital letter A only. Okay, so here then read operation we are doing on A. Okay, then write operation we are doing on something as a consider as a B. Okay, so again here also some transactions, then after that some transactions. Okay, so this is the time. Okay, here time T will be there. So same thing here, time T will be there. Okay, so here what we are doing is just read A, maybe we will do it here. Okay, so immediately here transaction T is read A will come. Okay, so this is write A will come. Okay, then again here maybe write B word will be there. Okay, so this is what maybe will combine it. two schedules, different schedule is different. Transaction operations are same. Okay, so in T1 also, T2 also, transaction operations are same. Okay, so S1 schedule is there, S2 schedule is there. Now S1 and S2 we can say as a conflict equivalent if conflict whatever are coming in this transaction are same as that of conflict whatever are coming in this same this transaction. Okay, so here if you saw here what we are doing is data item A we are writing it, then here reading it. So write read conflict is there, so like that here it is there. Yes sir, no. Okay, so here reverse of that is there, that is here reading then after write is there. Okay, so this is not a conflict serializable. Okay, so this example whatever we took, it's not a conflict serializable. So it may happen as a something, some different operations maybe will perform it or different order will perform it. So that time your order of conflict will come same thing. So that is here after writing A read whatever we're performing same thing. Suppose here also, so maybe here also what we have is same order we have. Okay, so consider as a here also read A. Okay, so here also same order, maybe here we don't have, maybe some other operations of A will run, then maybe here we're running it. So otherwise both will look like exactly same. Okay, so instead of here running both together then this side operations, so maybe some operations are running here. Okay, then here T2 transactions some operations are running here. Okay, so do the right B like that. Okay, so what will happen both side, that is after writing A here reading, so here also after writing A we are reading it. So now like that all the conflicts are same, so that time S1 and S2 will say it is a, this is a both are conflict serializable, conflict equivalent. Okay, so clear, this is both are conflict equivalent. Then next one will come as a conflict serializable. Okay, this schedule S is said to be a conflict serializable if it is conflict equivalent to some serial schedule S dash. So whatever yes we are doing it, so in that conflicts will be there. Okay, so for that is if serial schedule we are writing it. Okay, so consider as a yes dash serial schedule we are writing it. So whenever you are writing a serial schedule, in that if any conflicts are there, so that conflict also is equivalent to the yes schedule. Okay, so we will call it as a, so whatever schedule is there, that schedule we will call it as a conflict serializable. Okay, so certainly you will be having it. So in that conflicts will be there. So those conflicts you have to check it with, that is a serial schedule of same transactions. So you can write that one easily, like because serial schedule is nothing but all transactions operations you have to perform at the same time. Okay, so if in yes if you have as a three transactions, so in yes dash what will be there, transaction T1 will run, then transaction T2 will run, transaction T3 will run. So 3 will run completely. So in that also same conflicts are appearing, means then we'll say as a whatever schedule yes is there, so that schedule is conflict serializable. So here being serializability is not the same as being serial. Okay, so both are actually different. That is serializability in that interleaving will happen. Serial actually without interleaving of any operation it will perform it. So being serializable implies that schedule is a correct schedule. Okay, so because actually our intention has to be bring the serial value. Okay, so it will leave the database in the consistent state. So and interleaving of appropriate and will result the state as if the transaction is serially executed. Okay, so it will get same as that of serial execution of result. Okay, and so why we are doing this one is for the increasing of the efficiency. Okay, so why we are doing the interleaving is nothing but to increase the efficiency only. So that one only it will give it a serializable schedule will give the efficiency compared to the serial schedule. Okay, so serializability is hard to check. Okay, and interleaving of operations occur in the operating system through the some scheduler. Okay, some scheduler will be there, from that only it will happen interleaving. But difficult to determine forehead how the operations in a schedule will be interleaved. Means this is the because we don't know in which order the operations will come. You can't predict like future prediction. Okay, so you can't predict the exactly futures how it will happen. It which are the operations will come. So interleaving of those things will also be a difficult part. Okay, so to achieving this one serializability is difficult part. So for this purpose, okay, so that's why we have in practically purpose we have some different algorithm kind of things. Okay, so algorithms, so how you have to go ahead come up with some methods or protocols to ensure the serializability, so how it has to perform it. Okay, so those things, so view equivalent, view serializability, and what is those algorithm, how you have to check it. Okay, so these things we'll study it in next class.